This video is going to be about some basics of Newton's second law and how we solve some pretty simple problems using Newton's second law and also the concept of net force. So we can have Newton's second law written as net force equals mass times acceleration. Also, sum of the forces equals mass times acceleration. Occasionally, it's actually easier to write it as acceleration is net force divided by mass. Oftentimes in a problem, you're looking for the acceleration, and you want to find the net force and the mass in order to find the acceleration. So here I have a pretty basic problem, 500 kilogram car resting on a road with no friction to start out to make it a little easier, an applied force of 500 newtons this way, an applied force of 1,000 newtons that way, and part one is finding the net force, part two is finding the acceleration. For a simple problem like this, you don't necessarily need to go through all of these steps, but I'll go through the steps. Some of you can quickly just look at the problem and find the answer, but let's talk about what we need to do. First of all, we need to draw a free body diagram. So let's do that over here. There's my car. I have gravity going down. And I can go ahead and write in 5,000 newtons if I want to for a 500 kilogram car. I have a normal force going up. And because I don't have any motion in this direction and I don't have any other forces in this direction, I can right away write that that's 5,000 newtons. And those are balanced. We don't even really care about these forces too much. I have an applied force in this direction of 1,000 newtons and an applied force in this direction of 500 newtons. I would really want to split things up into x and y direction, but I think you can see pretty quickly that there's nothing very interesting going on in the y direction. We just have a force up, a force down, those are balanced, no big deal. So let's just start out with the x direction. And what I want to find here is I want to find out what's the net force in the x direction. What's my net force in the x direction? Well, I have two forces, 500 and 1,000. Let's say going to the right is the positive. So I can write that my net force is going to be 1,000 newtons minus 500 newtons. No surprise, the net force is 500 newtons. So that's pretty easy to do. Great. Now let's look for acceleration. Just using this one, acceleration is F net divided by m. My net force was 500 newtons, and my mass is 500 kilograms, so I get 1 meter per second per second. The units are always going to work out to be meters per second per second. In fact, buried inside of this newtons right here, if you remember, 1 newton is the same as 1 kilogram times meter per second per second. So if I take this, newtons, and divide it by my kilograms, I'm just going to get my meters per second out of it. So that's a pretty basic problem with no friction. Let's erase things and let's add in friction inside of here, and we'll make something a little more interesting. We'll take this away. I'll take the no friction part away. Take that away. Okay. So now let's say that we add in a friction force. I'm going to actually tell you what the coefficient of friction is, mu, and it's going to be a kinetic coefficient of friction. I'm going to assume that the car is actually moving here, and we'll make it 0.1. So we'll make a kinetic coefficient of friction of 0.1, and now I'm going to change up these forces as well, just to make things a little bit easier. So let's say that this is now 2,000 newtons, and this is 300 newtons. So we're going to have the same problem here. First, we're going to find the net force, and then we're going to find the acceleration. So the free body diagram is going to change a little bit for us. We still have gravity going down and normal force going up. Those, once again, we don't care about too much. I still have my applied force in this direction, an applied force of 2,000 newtons in this direction, and then I still have an applied force in this direction, and this time it's 300 newtons. And now I have a friction force that I have to deal with. The friction force is always going to be parallel to the surface between the, parallel to the plane of the surface between the objects there. So my friction force is going to be in this plane, and I have to try to figure out, is my friction force going to be going to the right, or is my friction force going to be going to the left? If you look at this problem over here and look at the diagram, I think you can see that the car is going to be accelerating in this direction, which means friction is going to be opposing that force, that acceleration. It's going to be going in this direction. Sometimes it's tricky to draw multiple forces in the same direction on a free body diagram. Just have to do your best. So I have another force coming back this way, and that's my friction force right there. I can't write in a number for it quite yet. I have to do one more calculation before I can write in a number for friction force. And I don't know if my arrows are really the right length right here. So how do we find out what the friction force is? Well, we actually have a formula that says friction force is going to be mu times the normal force. And since I know mu and the normal force, I can actually figure out what my friction force is. Oh, I should have written these down. 5,000 newtons, 5,000 newtons right there. Good. So my coefficient of friction is 0.1, 0.1, and then my normal force is 5,000 newtons. So now I can figure out that my friction force here is actually 500 newtons. So you may have seen I hesitated when I was making up these numbers because I already could think a little bit in advance. I knew if I had a coefficient of friction of 0.1 that my friction force was going to be 500 newtons. The way I had it written before was 1,000 and 500. If I added in another 500 that way, they would have been balanced and I wouldn't have been moving. So I had to think about that for a moment. So if you go back and look in the video, I have this little hesitation. But now it's going to work out, so don't worry about it. But with these numbers, it's going to work out a little bit better. So now I have my friction force here of 500 newtons. 500 newtons. And once again, I'm left with trying to find out my net force. And this is in the x direction, what's my net force? We'll choose this 2,000 to be positive. 2,000 newtons minus 500 for friction, minus 300 for my other applied force. So 2,000 minus 800. So now my net force is 1,200 newtons. Over here, 1,200 newtons. Finding my acceleration. Acceleration is net force divided by mass. My net force, 1,200 newtons, divided by my mass, 500 kilograms. So I believe that's going to give me, so I can get rid of those two and those two. So I get 12 fifths, which is the same thing as 2.2 and 2 fifths, 2.4 meters per second squared. I think that's right, 2.4 meters per second squared. So this is how we would work out with something with a coefficient of friction. Now, of course, things can get even harder. So should we do one other tricky problem? Okay, why not? Let's do one more tricky problem. Since you're here and since I'm here, let's just go ahead and do it. Take all this down. Separate problem. Let's go back to a good old box resting on the floor. Let's make the mass of this box, I don't know, 10 kilograms. Let's have an applied force going this way. And we'll make that, let's see, I know that's going to be 100 newtons. So I don't want my vertical piece to be more than 100 newtons. So let's make this 20 root 2 newtons going that way. So that's going to happen over there. So 20 root 2 newtons. Let's go ahead and give us a coefficient of friction right here. And let's say that my coefficient of friction is, actually, okay, good. We'll give a coefficient of friction of 0.2. And let's see what happens. I'm not sure if this is going to work out, so just stick with me. Let's see what happens here. I want to find out the net force and I want to find the acceleration. Good? Okay. So let's draw a free body diagram here. And free body diagram is going to go like this. I've got gravity coming down. I've got a normal force going up like this. And I've got my applied force, which is going to go off in this direction. And then I've got friction, which is trying to slow me down in this direction. Good? So I want to be able to find my friction force. In order to find the friction force, I have to find the normal force. In order to find the normal force, I have to break this applied force into components. So I'm going to do that over here, this way and this way. 20 newtons and 20 newtons. Guess I should write in over here that this is 100 newtons going down like this. So I don't know what my normal force is yet, because I have to use the applied force in the vertical direction. So let's do that really quick. In my y direction, let's figure out that I have to have the sum of my forces has to be 0. In my y direction, my box is not going to move. So the sum of my forces in the y direction has to be 0, which means that down is negative, up is positive. I've got normal force plus 20 newtons minus 100 newtons equals 0. So that's that, that, and that. Now I can figure out that my normal force has to be 80 newtons. Okay, those all have to balance. So let's write this in. 80 newtons, just like that. Good, so now what can I do with that? Now I know that my friction force is mu times my normal force. So that's going to give me 0.2 times 80. Good, 0.2 times 80 is going to give me, let's see, 0.2 times 80. So that's going to give me 16 newtons for my friction force. So that's 16 newtons. Now I can deal with things in my x direction. Let's do that down here. X direction. What's my net force? So I've got something going this way and something going this way. I've got 20 newtons for my applied force and 16 newtons for my friction force. So that's going to be 20 newtons minus 16 newtons. That's going to give me 4 newtons is my net force. So I can write that in over here. 4 newtons. Can find out my acceleration. That's F net over m. 4 newtons divided by 10 kilograms. That's going to give me 0.4 meters per second. So a little bit trickier of a problem. When you have an applied force at an angle, you have friction. The free body diagram gets a little bit more complicated, but I think you can do it.